So I want to show you my project. It's done with an esp8266 triac, and basically it's a light switch that has voice control, internet control, and also has the normal on-off control. So first of all, let's see it working. I have everything in an electric box. Everything fits in an electric box. You see there's enough space for the connectors. I have a few parts which I 3D printed. Then you have the wall plate. Everything is connected to a power source, and then it has a 50 watts incandescent light bulb attached to it. Here I have the Google Mini, which is already set up. So let's see. Hey Google, turn the light on.
I am turning the light on.
Hey Google, turn the light off.
I am turning the light off.
Okay. And also, if we want to use it in a manual mode, you'll see here there are two buttons. This is the on button and this is the off button. There are tactile switch behind them, so you don't need to press it just a bit. See? But I tried to keep the same shape. I'm going to show you now of a normal switch, so it feels the same thing on the wall. Okay. Now a bit about the project. As you see, it doesn't require any external tools. Everything is built in. Let's try it one more time and then we're going to look and see what's inside the box. Hey Google, turn the light on.
I am turning the light on.
Hey Google, turn the light off.
I am turning the light off.
Okay. So now let's unplug it. And I'm gonna try to hold the phone and see if I can show you guys what's inside. So let's start disassembling it. First we're gonna take out these screws. This is a full product that I want to install in my house. Right now I'm in the testing phase, meaning I want to see how much power can this circuit drive without overheating, and so far it can do 100 watts without any problem. You're gonna see. Okay, so first of all, okay, and now let's take the other screws off and I'm gonna show you guys what's inside. As you see here, you have the 8266. I don't know if it's focusing. Second. 8266 with two tactile switches. Micro switch, I think it's called, this one. This is not the real SMD version, it's the version through holes, but I've installed it on this side. Okay, and now let's take everything off of here. So as you see, this is a normal electric box. I removed one side to be able to do all the measurements when I printed the 3D parts. Okay, here we have the box, the 3D part, the 3D printed box, which looks similar to this one. This is the first design that I did. And then this one. And then I was able to cut a bit more of the height here. So you see this is even thinner. Now the board itself, it consists of two PCBs. The first PCB, this one, is the low power and low voltage PCB. This is only the 8266, and the voltage that gets to it is only 3.3 volts, so there's no danger in touching any of this. Anyways, they are covered by the plate, but the idea is that this is safe. They are connected through some headers to the second board that consists of, first of all, it's a 110 to 3.3 volts power source, and AC to DC. This one, it's bought out of eBay for a few dollars. Then you have the connector, and between those you have a BT, I think it's a BTA or TIC. Let me see which one I have in this version. Yeah, it's a BTA 16. It's a triac, and this is an optocouple for this triac. So this way, how does it work? 110 volts get in here, gets powered here. Then you have 3.3 out of out of this part. It goes to the header to the Arduino, to the ESP8266. Now this one has two switches which have an internal pull-up resistor, and they are connected to ground. So whenever I'm clicking this one, it just puts that pin, the corresponding pin, to ground. Then in here I have multiple IOs that go to the second board. Normally I only need one to control the octocouple of the TRIAC, but I'm thinking already of an upgrade for this one. I want to install a small heatsink to the TRIAC and also install a thermocouple, a thermistor to it, and then I'm going to connect the thermistor to one of the pins in here. And also I'm going to create a protection, an overheat protection. So if someone connects, for example, a 500 watt, the BTA 16 can take up to 16 amps, 600 volts, this version. So it will be able to drive that 500 watt, but it will get really hot. So it needs a heat sink. But the idea is that I'm going to see what's the maximum immediate temperature of this one without destroying it. I don't know if there's an internal protection for that or not, but anyway, the thermistor will cut the power, will cut the signal from the 8266 when this one becomes too hot. So that's why I have multiple pins. Normally I should have only one pin. As you see in here, I have 1, 2, 3, 4, 5, 6, 7, 8. So two of them, first of all, are the power, the 3.3 volts is ground and plus. Then I have the RX, TX, I have the GPIO 15, I think it's called, the GPIO 0, the one that you have to put to ground and programming. I have the ground, and then it looks like I have two pins, two input-output pins connected. In here, I have the connector for programming this board. As you see it, it's right here, so it's available when the box is mounted. You have the RX, the TX, the GPIO 0 or 15. I'll have to look again which one is the one that you have to connect to ground, and the ground pin. So you can change the program inside the ESP without taking it off of this board. Okay, now, so things are pretty simple. This one has a handler inside that listens for a connection on port 80, and then it has a parameter that turns on and off, and based on that parameter you get an output high or low on the pin that's connected to the TRIAC on the second board. Now, how does the Google work? It's connected to if this then that. Then that goes to my router at home, which has a network address translation, so port forward from a specific port that if this then that commands to my device. That's it. If you're interested, like and share this video. I'm gonna post soon the diagram. I'm gonna post the PCB diagram, the circuit, and if you have any questions or improvement about these ones, I'd like to hear from you. I'm also gonna post, see in here I have already designed a few wall plates. This one is missing some spacers. I improved from the first version to the last one. Now this is the latest version. It has here exactly where the contacts are coming. I don't know if you're able to see. See, this will come exactly, and when we move this plate, this is about 0.4, I think, the width of this part, so it's somehow flexible. See, and there's enough movement for it to push one of these buttons. So right now, as I've told you, it's tested with this TRIAC. It's tested to 100 watts, and the TRIAC in half an hour of usage gets to 44-45 degrees and stays there, degrees Celsius. I've tested it even with 500 watts, but it gets hot like 100 degrees in 2-3 minutes. So the TRIAC gets can drive up to 16 amps, but it needs a heat sink for this. So I was thinking in a next design, because I have enough space in here. If we're gonna put this again, I'm sorry. If we're gonna put this again, I have enough space in here, so I could build somewhere over here. I could build a heat sink for it. Okay, or even a small fan. I don't know, because my TRIAC it's exactly in here or the other side, so it's accessible. It's right at the edge of the box. Okay, that's it.